Hello, geometry folks. Welcome to another edition of your notes. Notes 8-2, similar figures. All right, before we get started, I want to remind you to make sure you copy down exactly what I write down, and your notes should look exactly like my notes. And yes, you should be tired of me saying that by now, but you should also be doing it. All right. First off, we talk about what similar figures are. Similar figures have some definitions, but first I want to talk about what this little symbol is. This symbol is a symbol for similarity. All right, much like the symbol for congruency is this little squiggly line with equals on the bottom, similar is just a symbol by itself. All right, similar figures, the exact same shape, but they're a different size. So it could be bigger or smaller, but the exact same shape from one to the next. A couple things that we know, two things that we know about similar figures. All corresponding angles are congruent. All right, and number two, I know that all corresponding sides are proportional. All corresponding sides are proportional. Okay, which is to say that if I've got one figure to the next, for example, a triangle, the corresponding angles are congruent to each other, and then my sides would be proportional. I could set up a proportion and solve for a missing side, like I'm going to do for my first example here. Example number one involves similar triangles. It says that triangle ABC is similar to triangle XYZ. So right here, my two triangles from A to B to C is similar to XYZ. Notice it goes in the same order. This right here is called a similarity statement. Similarity statement. Okay? And we will practice writing those together momentarily. All right? So the first thing it says is to find the scale factor. Scale factor is just another word for ratio. So let's put that in parentheses here. Ratio. Scale factor just means the ratio. All right? So the scale factor from one figure to the next, well, here I've got my corresponding sides, AB, is going to correspond with side XY. I can see that from my similarity statement. AB goes in the same order from X to Y. All right, so I can match up the corresponding sides to make a proportion, or I'm sorry, I can match up the corresponding sides to make a ratio. I've got one side is 20, corresponding side is 25. Always simplify. I can divide both numbers by 5. So 20 divided by 5 is 4, and 25 divided by 5 is 5. So my scale factor, or my ratio, from one figure to the next is 4/5. Next, it wants us to find the length of AC. AC is right here. I'm going to call it X instead of a question mark there. So if I want to find what that side is, I can set up a proportion. One thing I forgot to say here. If all corresponding angles are congruent, that means from one figure to the next, okay, the angle A is congruent to angle X. Okay, angle B then is congruent to angle Y, and then angle C is congruent to angle Z. Congruent meaning they have the exact same measure, so A is the exact same measure as X, B is Y, and C is Z, and so on and so forth. Okay, so the corresponding sides are then also proportional. So I can set up a proportion to solve for my X. Well, I can use my scale factor, or I can choose the numbers it gives me. I'm going to use the scale factor since that's what it gave me. That's what I found. 4/5 is going to be equal to, from one figure to the next, then I go the same direction. AC corresponds to XZ, so equal to X over 15. And then just solve for X. So cross multiply. Got 5 times X is 5X, is equal to 4 times 15 is 60. And then divide by 5 on both sides. So X comes out to be 12. All right, so the length of AC is 12. That would make my sides proportional. 20 to 25 is the same ratio as 12 to 15. All right, example 2, we were working with similar polygons. It says the polygons are similar here. So these house-looking shapes are polygons. A polygon is a close-sided figure. All right, these two polygons are similar to each other. It says write the similarity ratio, and then write the similarity statement, and then also solve for X and Y. So a couple different things. We're going to do all three of those things right now. All right, so writing a similarity ratio is going to be from one figure to the next. Okay, match up the corresponding sides. So I'm going to find a corresponding side here. I've got 18 corresponds with 4. So if I want to write the ratio here, the ratio from one figure to the next would be 18 over 4. Simplify that, you can divide both by 2. So we get 9 over 2 is our similarity ratio. All right, next it asks for a similarity statement. My statement is this figure is similar to this statement here. So statement. So if we go in order here, let's start with R. So and then RSTUV. So RSTUV is going to be similar to just the squiggle line A, B, C, D, E. Okay, I can match up corresponding angles, corresponding sides, proportional sides, so on and so forth. Next it asks to solve for x and y. Well, here's my x. The side that corresponds with my x is 3. So I could write out my proportion to solve for x. Let me just go ahead and use the dimension it gives me, not worrying about simplifying. It doesn't really matter. If I say 18 over 4 is going to be equal to, from one figure to the next, x over 3. Then do my cross multiplication. So if I have 4 times x is equal to 18 times 3, which is 54. Then divide by 4. So x is equal to 13.5. All right. Then to solve for y, match up the corresponding sides for y. Here's y plus 2. That corresponds with 5. So set up your proportion the same way. 18 over 4 is now going to be equal to y plus 2 over 5. Make sure you go the same way both times. All right, be careful here when I'm multiplying by this. Think about y plus 2 as being one term. So I've got 4 times that y plus 2 is equal to 18 times 5, which is 90. Then distribute that 4, like the good math students that you are. 4 times y and then 4 times 2 is equal to 90. Subtract that 8 over. So 4y equals 82. Divide by 4. So y is going to be equal to 20.5. All right, last example. Example 3, ratios in triangles. In a triangle, the ratio of the sides is 5 to 12 to 13, and the perimeter is 90 centimeters. Find the measure of the shortest side. Be careful you make sure you actually find the shortest side. It's being specific there. All right, I could draw this out. If I have any triangle, the ratio of my sides is 5 to 12 to 13. 5, 12, 13. The sides are not actually 5, 12, and 13, so I got to incorporate or put an x with this as well, because it's a ratio. There's a multiplier here that goes with each one of these numbers. If I know the perimeter is 90 centimeters, okay, I can add up all the sides and say 5x plus 12x plus 13x is going to be equal to 90, and then just solve for x. If I combine all my x's there, I get 30x is equal to 90. Divide by 30, so I get x equals 3. That's not the question it's asking. It's asking for the shortest side. My shortest side will be the ratio with 5 here. So the shortest side can be found with my ratio of 5. Well, my x is 3, so 5 times 3 is 15 centimeters is my shortest side. All right, and I can multiply 3 times all the rest of them as well, but no, not needed. 15 centimeters is it. All right, guys, make sure you fill out the WSQ. Have a great day.